So welcome to Everyday Mathematics. Today we are going to look at the Saginaw Valley State University 2022 Math Olympics. And we'll be looking at level 2, problem number 1. The way this problem was formulated is kind of problematic because there's a mix of things. But it tells us that for k greater than 2, small k greater than 2, and let's assume that capital K of n is equals to 5 times 10 times 17 times 26 all the way up to n squared plus 1. And then S of n, capital S of n, is equals to 1 minus 1 over 2 to the 4 times 1 minus 3 to the 4 all the way times 1 minus 1 over n to the 4. What is capital Sn over capital Kn? So you realize the problem here really is in identifying what the small k is all about, and that is not really clear in the problem, but I'm assuming the small k is just an index, so that in other words, capital K to the n is the product of from k equals to 2 to k equals n of k squared plus n. And then capital Sn is the product from k equals to 2 to k equals small n of 1 minus 1 over k to the 4. I think that's what the problem is all about. So we're going to try and see what Sn, capital Sn over Kn is. Now the good thing about this problem is it had a couple of objective answers to choose from. So we're going to see those answers or the possibilities from which to choose the correct answer. So we're being told that possible answer A is 1 over 2 times 1 over n factorial squared times 1 plus 1 over n. Could that be the answer? Option B, 1 over capital Kn times n squared over n to the 4th plus 1. Possibility C, n to the 4th plus 1 over 2 to the n plus 2 times 1 over n factorial. Possibility D, 1 over capital K to the n times 1 n to the 4 over 1 times 1 over n minus 1 factorial all to the power 4. And then possibility E, none of the above. So let's go and try and solve the problems and then see which of these possible answers is the correct answer. So for k greater than 2, greater or equal to than 2, if these are k, capital K to the n and capital S to the n respectively, then what happens is we could re-express our problems or our expressions as this. So Kn is the product from k equals to 2 to the n of k squared plus 1. Capital Sn is the product from k equals to 2 to k equals to n of 1 minus k to the 4th. Which can also be expressed as you could have a common denominator of k to the 4th, so that this is the product from k equals to 2 to n of k to the 4th minus 1 over k to the 4th. So what happens when we divide? So if this is our k n, then Sn could be expressed as a difference of 2 squared. So as we can see here, we can express it as the product from k equals to 2 to n of k squared minus 1 times k squared plus 1 over k to the 4th. This is simply a difference of 2 squares. Here, this is the same as k squared squared minus 1 squared. So if you have a squared minus b squared, that is the same as a minus b times a plus b. So that's what we've done here. K squared minus 1 times k squared plus 2 plus 1. So what is Sn over Kn? So we can then just divide the products. And as we can see, a product of items, if I'm, for example, multiplying A times B times C times D plus times E over F times whatever, all the way up to K, that is the same as just multiplying. In other words, you can bring the multiplication out and then divide the items you are multiplying, right? So in other words, this is the same as the product from k equals to 2 to n of, as you can see, this k squared and this k squared divide, so they cancel each other, and you have k squared minus 1 over k to the 4th. And you multiply this throughout. Okay? So this is where we've come to. We can divide through with k to the 4th, but I think the first thing is just again use difference of two squares, and that means that we do have, if we pull 1 over k squared out, we have the product from k equals to 2 to n of 1 over k squared times k minus 1 over k times k plus 1 over k. So this is where now you need to have your antennas pulled up and or straightened, and from here we can see that we can express or expand this out so that we try to see which items can cancel out. So I decided, you know what, I could pull out the 1 over k squared and then focus on whatever is out here. So this is the same as 1 over k squared multiplied up to n is the same as 1 over n factorial squared. So I've pulled that item out. And because this is the same as 1 over 2 squared times 1 over 3 squared times 1 over 4 squared. And you realize that's the same as 1 over 2 times 1 over 3 times 1 over 4 up to 1 to n times 1 over 2 times. So in other words, we come back to 1 over n factorial squared, and that is an easy derivation. Here, if we blow it out a little bit so that we see what we're doing, from k equals to 2 we have 1. So when k equals to 2, this becomes 1, so 1 over 2 times this becomes 3 over 2 times 2 over 3 times 4 over 3, all the way up to we have n minus 1 over n times n plus 1 over n. So there are some things that can cancel out, and we're going to see that. Okay, so if we cancel this 2 and this 2, and then this so we have 2 2 3 3 3 3 4 4 5 5 and then 4. So you realize that these intermediary parts cancel out. Up to here you see this n minus 1, this n minus 1 cancel, this n and this n cancel, and they all go away until we are left with 1 over n factorial squared times this half here that persists times n plus 1 over n. And then if you divide through with n, we have 1 over 2, could pull the half out, over 1 over n factorial squared times n divided by n is 1, 1 divided by n is 1 over n. And so this is the answer, and we can now go back and look at the possibilities of answers that we're given, and clearly we see A here is the answer that we're looking for. So that actually was what was being sought for, an interesting problem. I hope you've enjoyed following along. We'll keep bringing you similar problems, and hopefully you will keep locked or keep looking forward to what we have in store for you. Until next time, have a great morning or evening or a great day ahead. Thank you.